When you're trying to solve for P and you're facing a formula wheel, the key is knowing which P formula applies to your specific problem. There are a few common formulas where P appears, and using the wrong one will obviously lead to incorrect answers. Let's go over some of them. One common formula is P equals I times R. In this formula, P represents power, I represents current, and R represents resistance. Another common formula is P equals E divided by T. Here, P still represents power, E represents energy, and T represents time. A third formula involving P is often encountered in financial contexts, namely P of N equals P of 1 times the quantity of 1 plus R raised to the power of N. This is the compound interest formula, where P of N is the future value, P of 1 is the initial principal balance, R is the interest rate, and N is the number of compounding periods. The crucial step is determining which formula is appropriate. The formula you select depends entirely on what information you already have available and what you are trying to calculate. If you know the current typically measured in amps and the resistance typically measured in ohms, then the formula P equals I times R is your best choice to find power. On the other hand, if you know the energy, usually measured in joules or watt-hours, and the time, usually measured in seconds or hours, the formula P equals E divided by T is the appropriate one to calculate power. Finally, if you are dealing with a scenario involving compound interest, where you know the initial principal balance, the interest rate, and the number of compounding periods, you would use the formula P of N equals P of 1 times the quantity of 1 plus R raised to the power of N to find the future value of the investment. For example, let's say you need to find the power of a device that draws a current of 5 amps and is connected to a voltage source that creates a resistance of 12 ohms. In this case, you would use the formula P equals I times R. Plugging in the values, we get P equals 5 amps times 12 ohms, which results in P equals 60 watts. The compound interest formula is irrelevant here because the problem doesn't involve any interest calculations. Therefore, using the correct formula is essential to obtaining the correct answer, and the right formula depends on the variables that you are provided with in the problem.